Hello data scientist, welcome to SkillKit. In this tutorial, we shall build a flight fare prediction app using machine learning and deploy it using Flask. Fare prediction is a classic time series forecasting problem that finds trends in past observations to make future predictions. Many popular flight booking websites today, including Google Flights, showcase important insights on how the current fare stands. Is it too high, too low, or typical? Past fare trends, and essentially helps in deciding what's the right time to book a flight ticket. Well, in this tutorial, we are going to do something similar by building a flight fare prediction app that takes travel details as input, like the departure date, arrival date, departure city, arrival city, stoppages, airline carrier, to predict flight ticket price. With this understanding, users may have a better idea of what the cost would be on their upcoming travel. Alright, I hope I have excited you enough already. On this note, let's get started. For introductions, we are SkillKit and we are on a mission to bring you application-based machine learning education. We launch new machine learning projects every week, so make sure to subscribe to our channel and also hit that bell icon so you get notified of all our new ML projects. This is the dataset we shall use as part of this project. It has 10,682 observations with booking details such as the name of the airline, date of journey, source, destination, route, departure time, arrival time, duration, stoppages, some additional info, and lastly the price, which is our target variable right over here. Now this is our step-by-step plan on building this project. First up, we load our dataset kept in the project folder. I have provided the GitHub repo and Google Drive links in the description part below for you to have easy access to our project files. Once we have the dataset, we perform a series of feature engineering operations to convert our features to their numeric representations like this. Then we do feature selection using sklearn feature importance and VIF multicollinearity check to finalize the features for model training. Finally, we train a random forest regressor model for flight fare prediction, and we finish up with the Flask deployment to run our app in a live environment. This is our high-level project flow. So at stage 1, we build our fare prediction machine learning model, and then at stage 2, we build a web app and deploy our machine learning model in a live environment using Flask. Now let's start off with this model building, which is stage 1. This is our project folder on Google Drive. Here this fare prediction model is our Jupyter notebook. Let's fire it up to get started. Alright, now we are on Google Colab. I have divided this entire code file into these easy to read sections. So before we do anything, first up, let's set up our environment where we install the required dependencies. I'll run this first cell. And then to have access to our project files within Google Drive, we will be mounting the drive to Colab by following these steps. Then we also go ahead and set up our working directory to our project folder within Drive. Then next up, we are loading our dataset. For minor details like what's the role of this set option display max columns none, I have provided these explanatory comments throughout this Jupyter notebook. So do refer to these comments for in-depth understanding of what's going on. So our dataset is now loaded and this is how it looks. We have all of these features, and towards the end we have this price column, which is our target variable. Then we are printing the information on our dataset, including the data types with this next cell. As you may see, all our features are object data type, meaning they have string values in them. And visibly so, right? We have all of these values as nothing but strings. And our target variable is a float, as we may see here. Next up, let's check for missing values. To do this, we are using this isNull function. We have a few missing values as we may see here. So let's go ahead and drop them with this dropNA function. And finally, we may now validate if the changes are done. So we see all zeros, it means we are good. Now we come to the all important feature engineering part where we perform exploratory data analysis on our dataset, which looks like this. In this current form, a computer may not understand these features or variables, which are basically object strings. So we need to figure out ways on how we may convert these features to their numeric representations. First up, we may pick up the date and time object variables like this date of journey, departure time, arrival time, and duration to derive numeric features using the pandas to.datetime method. Like for this date of journey, we extract the journey day and journey month using pandas to.datetime method to convert object to datetime data type and then use dt.day and dt.month attributes to extract journey day and journey month and store them in two new columns within our data frame. Here we have these new columns now in our data frame. Now you may think why we are not extracting the year value here. It's because our entire data set is for the year 2019. So it's not going to add any value even if we extract it. So we are not doing it. Now, once we have our two new columns, journey day and journey month, we may go ahead and drop the original date of journey column from our data frame as it is now redundant. So let's do it. Then we do the exact same thing for departure time and arrival time with this next couple of cells where we are extracting hour and minute value and creating new columns in our data frame for storing them and then dropping the original features. This is how our data frame looks now with these changes. We have a couple of new columns each for the departure time and arrival time. Now let's talk about duration. As you may see here, duration is represented in X hours and Y minutes format. However, some values also have only hours and some may have only minutes. To fix this, we are looping through duration with this next cell and checking if the length of duration split is not equal to 2. If it is not, then we are checking if it has the minutes part missing or the hours part missing. And accordingly, we add 0 minute as suffix and 0 hour as prefix to standardize duration as a feature. And finally, we extract duration hour and duration minute from the now standardized duration value and add them to the data frame. This is how our dataset looks now with the two new columns. Alright, now we have successfully derived numeric features from our object variables. Next up, we have categorical variables, airline, source, destination, route, total stops, and additional info. Categorical variables can further be of two kinds. First one is nominal, where categories do not have any order. For example, airlines, we cannot arrange them in some ranking order. For nominal data, we use OneHotEncoding for representing them in a numeric form. And the second one is ordinal, where categories may have an order. For example, total stops. As a user, I may definitely prefer 0 stops the most, then 1, 2, and so on. For ordinal, we use LabelEncoding for numeric feature representation. With this understanding, let's get started with the first categorical variable, which is airline. As we know now, airline is nominal data, so we shall perform OneHotEncoding here. For this, first we check for value counts. As you may see, we have Jet Airways, Indigo, Air India, etc. here. And towards the end, we have these carriers that have low value counts like TrueJet, Vistara Premium Economy, Jet Airways Business, etc. So we may define a new category here called Other, where we may put all these carriers having value count in double digits or less. For this, we have this script here where we first define a new data frame airline and assign the dataset airline column to it. Then we loop through our airline values, replacing low value count carrier names with other. Let's execute this now. And now when we check for value counts again, we see the new category others with an aggregated number. Now we perform OneHotEncoding on the data frame airline using pandas getDummies method. Let's do it. And with this, we have our airline data frame transformed to OneHotEncoding representation here. Now let's move on to the next feature, which is source. Here are the value counts that look fairly distributed. So we may directly perform OneHotEncoding here. For this, we first define again a new data frame called source and then call pandas getDummies method on it. And with this, we have our source data frame transformed to OneHotEncoding representation. Next up, we have destination, and here is the value count. If you go through these values, you will find a minor issue here. Yes, we have these two labels, Delhi and New Delhi, which are basically the same cities. So we need to merge them into one now. For this, we apply a similar logic to what we applied for the airline feature. Basically, we define again a new data frame destination, having a single column destination from our dataset. Then we loop through destination and replace all New Delhi with Delhi. And finally, we perform OneHotEncoding with the pandas getDummies. And this is our destination data frame like afterwards. Now moving on for the next couple of features, route and additional info. We are actually going to drop them. Route is a redundant feature as we have total stops that essentially captures similar information on total stoppages. And for additional info, 80% of the observations say no info. So it pretty much doesn't add value. So we are going ahead and dropping them. Now total stop is ordinal data, which follows an order like 0 stops is better than 1 stop is better than 2 stops, etc. So for this, we are going to perform label encoding. To do this, first let's check for value counts. Then as part of label encoding, we assign keys to total stop categories from 0 till 4 and replace the original values with these keys. So this is how the label encoded total stops feature is like now. Well, with this, we have completed the never-ending feature engineering part now. As a final step, let's concatenate the new data frames that we created like these airline source and destination with the main dataset, and now we are calling it data train. And separately, we also drop the original airline source and destination columns from our dataset. So this is how our final dataset is like now. And this is the shape of our data train. So now essentially we have 25 features to train our flight fare prediction model if I exclude the target variable price from this 26. However, not all of these 25 features would be of the same value for training. And in fact, few of the features could be highly correlated among themselves, leading to a condition we call multicollinearity. Now to check for the relative importance of features and for checking for multicollinearity, we are using sklearn feature importance and variable inflation factor or VIF respectively. To proceed further, let's first define our X and Y. X is all the columns barring price, and y is the target value price here. Now let's jump into the first part of our feature selection, which is feature importance. We use the following script to compute feature importance on all our features under X. Let's hit this. In return, we get these coefficients for all 25 input features. To better read these values, let's plot them on a graph with this next script. So here we have all our features listed in the ascending order of their importance in predicting the target variable price. Now let's also check for multicollinearity before we make a decision on feature selection. For this, we have written this function calculate VIF in this first cell, and then we are calling this function on our X. So here we have the VIF values on all our features. As a rule of thumb, VIF value of greater than 10 is generally a sign of multicollinearity. Here we are getting the highest VIF values for journey month and source Delhi features. And if we look at the feature importance on these variables, we find that source Delhi, which is here, has lesser importance than journey month, which is here. So we may go ahead and drop source Delhi from our feature set. So with this code cell, we are redefining our X, this time without the feature source Delhi. Now let's compute our VIF values on all our features once again. As you may see, we may still find some VIF values over 10 here. On the other hand, their feature importance is high as well. Hence, it's a trade-off we have to make to prevent overfitting at the cost of reducing model performance. So I leave this part to you on doing further permutations in selecting your final set of features and observing how the model performance gets impacted with those changes. And do share your experience on this in the comment section below. Now let's proceed to model training. To start off, we split our dataset into 80-20 training and test. And then we train our random forest regressor model on the training set. Guys, congratulations to you for making it to this point. Do give yourself a pat on the back for training your model all by yourself. As the next step here, we check for model performance. We are getting a training R2 score of 95% and test set R2 score of almost 83%, which is decent. Let's also build a scatter plot. In this, we see a good linear relationship between our actual test set prices and the predicted prices. For our regression model, we may also compute the model error values. Here we have these mean absolute error, mean squared error, and root mean squared error values. Normalized root mean squared error stands at 0.06. Normalized RMS value lies on a scale of 0 to 1, and a value approaching 0 is considered good. So in our case, the model is actually doing a fair job in predicting the price. And finally, we go ahead and save our model PKL file back to our project folder for deployment. With this, we have our flight fare prediction model ready for deployment. Now, just to give you a first-hand sense on what it takes for us to use our model for prediction on fresh unseen data, I have prepared this separate unseen dataset file. This unseen dataset has around 700 observations along with price labels. Let's use our newly built model now to make predictions on these unseen observations. For this, I have written this next section. within our Jupyter notebook. Here first up, I load the model file from the project folder. Then I load the unseen dataset. And then we perform the same set of feature engineering steps here on this unseen data as we did while model building. So here first up, we are performing feature engineering on object variables date of journey, departure time, arrival time, and duration using the exact same script we have used previously. Then we also perform feature engineering on categorical variables like these airline, source, destination, and total stops. So with this, we are essentially bringing our unseen data into the same exact form as we had in the training. Now let's perform this feature engineering on our unseen dataset. And this is how our unseen dataset transforms to post feature engineering. It looks the same, right? And finally, we define our X and Y, and the X here has the same set of features that we selected a while back for model building, excluding source Delhi. And finally, we feed these unseen observations to our random forest model for predictions. Then we can gauge model performance using this next code cell. We are getting a normalized RMS of 0.05, which is healthy. And towards the end, we write the output file along with the predicted price back to the project folder for our later reference. Guys, if you have any questions at this point, do post them in the comment section below and I'll respond to them. Towards the end here in this Jupyter notebook, we have hyperparameter tuning, with which we can optimize our random forest model parameters to further increase its performance. I'll be discussing this hyperparameter tuning part in my next tutorial, so do subscribe to my channel if you haven't done it yet, so you don't miss that important update. Alright, now we are done with the stage 1 of model building, and we are now all set for deployment of our flight fare prediction app. For this, let me open up the GitHub repo for this flight fare prediction project to get started. So now I'm on this GitHub repo for our flight fare prediction project. As you may see over here, we have all our project related files that we are accustomed to now. Plus we have this app.py, requirements.txt, and this template folder that has our HTML code file that gives a cool front end to our project, this home.html. Now before we start our deployment part, let me quickly give you overview of a web app, which is this app.py here. A web app is basically an orchestrator that takes user queries from the HTML frontend, transforms the query data into a form acceptable to the prediction model, and then calls the model on the transformed query data, and finally reads the model prediction and prints it back onto the HTML frontend page for this user's reference. Now within this web app app.py, we are providing everything that this app may need in order to run smoothly. Like we are first importing all the required libraries here in this first part so that the model doesn't have any issue running. Then we are loading our prediction model. And in this third part, we are defining a query handling mechanism wherein we have a home page, which is basically our home.html file kept in the templates folder as I showed you. Once a user fills in all the travel details and clicks on predict on this home page, this predict route is called upon. In here we have defined a predict function that basically computes our required features like these journey day, journey month, departure hour, departure minute, arrival hour, arrival minute, duration hour, duration minutes, and total stops. all from the user input using the same logic we have used earlier while model building. For the categorical variables airline, we are preparing data in the OneHotEncoding form, just the way we did for model building. If the user wants a price prediction for airline Jet Airways, then all the OneHotEncoding parameters will take this form. And likewise for the remaining airlines. And the same thing we are doing for the other two categorical variable, source and destination. And once we have all of our variables prepared in the required representation, we feed them to the model for prediction. And the prediction returned by the model is displayed back onto the same homepage.html for this user's reference. And our app.py gets this entire process executed within a split second and returns the prediction back onto the front page. And by the way, the detailed instructions on how to run this Flask app.py is provided in the README part of this GitHub repo. I know you guys can't wait to see this app in action now. So let's get going to run our app in a live environment. Within this Windows Explorer, I am in this projects directory right now, where I generally store all my GitHub projects. So as the first step, let me clone this project GitHub repo into this projects folder. To do this, I'll follow this GitHub README guide for Windows because I have a Windows machine. If you have a Mac, you may follow this set of instructions. I already have Git Bash installed, which is a prerequisite before you get going with these set of instructions. Alright, as a first step, I do a right click within my Windows Explorer and open the terminal. I'll keep it here. You may also search for it in the start menu and open it up from there. Benefit of right click open is that my working directory is automatically set to the projects folder with this approach. So this is the one I generally prefer. Now once I am in this working directory, I run this command to clone the Git repo. And you may see that this flight price prediction folder has gotten created. Alright, now I'll change my working directory to this flight price prediction folder. Alright, now I install virtual env into my machine as per the next readme instruction. For this I say pip install virtual env. Once done, then I create a new virtual environment within my project directory with this next command. Let's run this. Once I do that, I see a new folder with the name env getting created in my flight fare project folder. This new environment is like a new system created within my computer with base Python 3.9, which is my system Python's version. Next up, as per the instructions, I activate my virtual environment. Now you may see that I am in env, the new environment, and then I install the requirements.txt, which essentially has a list of all the dependencies that are required by my project. Alright, so our environment is now fully set up to run our app.py, which is this. So let's say Python app.py. And as you may see, our app is live now on this localhost URL. Just copy this and paste it in your browser. So with this, we have the result of all our hard work in front of us now. What you see here is the home.html page that we have in the templates folder in our project files. Now let's make a query to our model and see what result we get. So I say departure date is 12th of August. I pick some time. For arrival, let's say I do it after a day. Traveling source, I'll keep Delhi. Traveling to destination, let's say Hyderabad. Number of stops, non-stop. And here I say Air India. Now let's call our model for predicting the price. So our model says that the price of this flight should be around 4,051, which seems fair. Do try out multiple combinations on your end and share your feedback on how it went in the comment section below. Guys, with this we have come to the end of this tutorial. Do give a thumbs up to this video if you liked it. In case you have any doubts or you got stuck somewhere, leave a comment below and I'll help you out. You may write to me over email, WhatsApp as well, or schedule a free one-on-one session on my website skillkit.com by filling out this small form. I post new machine learning projects every week, so do subscribe to my channel. Happy learning to you. Bye.